Okay, let's finish this chapter with profiling Python. Okay, there are a few different ways to profile a Python application. Profiling means having the application run while keeping track of several different parameters, such as the number of times a function is called and the amount of time spent inside it. Profiling can help us find the bottlenecks in our application so that we can improve only what is really slowing us down. If you take a look at the profiling section in the standard library official documentation, you will see that there are a couple of different implementations of the same profiling interface, profiling and cProfile. cProfile is recommended for most users. It's a C extension with reasonable overhead that makes it suitable for profiling long-running programs. Profile is pure Python module whose interface is limited by cProfile, but which adds significant overhead to profiled programs. Let's create a new folder called profiling, and inside I'll create a file called triples.py in plural. Okay. Well, let's define a function div called hi triples, and inside I will define a list of triples. It will receive mx as parameter. Let's define a for buckle here, for loop, a in range mx plus 1. Okay, and inside we see something similar, mx plus y plus 1. Okay, but in this case it will be the variable b. Let's calculate a hypotenuse. Calc hypotenuse. Let's pass a and b. Okay, and let's evaluate if is int hypotenuse. Okay, and we see triples dot append and a b and int of hypotenuse. Now outside I will say return triples. Okay, of course we need to define calc hypotenuse function as the same way is int. Let's define it outside. Def hypotenuse, I will see a v and return a with a power 2 plus b with a power 2 and we at a power of 0.5. And similarly def is int which return and thus is integer. Of course you will receive n here, and right here we will spec n is expected to be float. Okay, So let's evaluate this code with triples equal to call triples 1000. Okay, now let's execute it a little different. Workshop cd chapter A, cd profile, and now I will pi m c profile and triples dot pi. You see? Okay, these are very different outputs till we see here. This group is extremely simple. We iterate over the interval on mx with AV, avoiding repetition of pairs by setting a v greater than a, and we check whether they belong to a right triangle. We use calc hypotenuse to get hypotenuse here for a and b. Okay, and then with this int we provide this script. We get information in tabular form. The columns are called n calls to t time per call, comp time per call, file name line no. Okay, they represent the amount of code we made to a function, how much time we spend in it, and so on. I'll trim a couple of columns to save space. So if you run the profiling yourself, don't worry if you get a different result here in the code. Something that I really like when I'm coding is in optimizing code. Let's see this function called hypotenuse. Okay, as I mentioned earlier in these lessons, the power, this 2 sign here, the power operator is quite expensive, and we are using 3 times here. Okay, fortunately we can easily transform to those in a simple multiplication like this, a times a and b times b. Okay, and also we can improve the function is int. You must say n is equal to int n, like this. Now let's execute it. If it's right, if we optimize or something. Okay, pi, the same code. Let's execute it. Okay, you will see that in this time it took 1.4 seconds. The time before took early almost 3 seconds, right? So with these changes, we optimize it just a little, but it's enough if we are thinking about large amounts of numbers. Okay, because this implementation is different, and the advantage is that it also works when n is integers. When we run the profiling against it, we see the time taken inside its int function has gone up to 0.315. Okay, you will see some different numbers. So something additional that I must mention is that depending on what system you are using, the result may be different. Therefore, it's quite important to be able to profile software on a system that is close as possible to when software is deployed on, if not actually on that one.